Hello there. Until now, we have seen few static analysis checks in our previous videos. Now in this video, we are going to explore the dynamic analysis checks and what kind of vulnerabilities we may find once we intercept the traffic. There could be access control related issues or any other API level vulnerabilities you may find when you're pen testing the APIs. So here I have my rooted device and the burp suite ready, and for this example we are going to use the damn vulnerable bank application. Now they have done some nice work into putting together this vulnerable application for educational purposes. I will also share the applications link in this video's description box. So let's start. So I have this damn vulnerable application installed in my device. So as soon as I open this application, there are two boxes, login and sign up. So there is some work that needs to be done to configure this application, but I am skipping that for this video because our focus is on the vulnerabilities rather than configuration of this application. So let's try to log in. Now as soon as you spin up this application, they will provide you some default credentials to log in. So I'm entering those username and password to log in. As soon as I clicked on the login, I got one request in my burp suite. Now it is a post request to the user login path, and there is only one JSON parameter that says ENC data, and it has a value that seems like an encrypted value. If we look at the response, there is a similar kind of setup where we see the encrypted value in the response, and we can't really see that what went in the request and what came in the response. So whenever we are testing the application, especially related to financial organization, you will see such scenarios wherein the encryption may be happening at the client side, and the response will also come encrypted from the server, and your Android app has to decrypt it. So at first glance this looks like base64. So let's go ahead and try to decode this one with the burp decoder. Decode is base64, and no, it is not base64. So definitely they have used some sort of encryption. Let's go back to a proxy and try to click on few more buttons. Let's click on my balance. Alright, there was one more API call triggered. It says API balance view. It is a post request, but there are no parameters, and in the response we are again seeing this encrypted data. But in our mobile app we are seeing that your balance is $10,000. Let's try to click some more buttons. We are going with transaction this time. Let's click on the transaction request. Again no parameters, and in the response we are seeing this encrypted text. So essentially the server is giving encrypted response in the application, and the Android app is decrypting the values and showing us the results. So as a next step, we need to reverse the application to understand how the encryption is being done, and after that maybe we'll be able to find some vulnerabilities, access control related issues in the application. So just like we have seen in the approach video, we are going to use our JADX GUI to open the APK file. So we have our JADX GUI over here. Now let's try to find few activities which we have clicked on earlier, just like get transaction button maybe. So I'm opening this get transaction activity, and most of the values, if you see, they are obfuscated, and we can't really make a lot of sense out of this. Let's look at the balance activity maybe. So here it is, view balance. All right, we are seeing this ENC data over here. So from the response, they are getting the JSON object ENC data and they are passing it to this method, that is A, that is E of A. Now E is class of this package, that is c.b.a.e. So we are going to directly jump onto here. So with JADX you can do that, just press Ctrl and click here and it will navigate to the responsible class. So now this class has basically three methods: method A, method B and method C. Now if you see closely here, it says decode. So whatever value whatever value coming over here, it is decoding the base 64 in order to give us the decrypted values, and this method is responsible for encrypting the values. But in this both methods there is a common method call that is happening, that is the C. So this is the actual code that is being that is responsible for encrypting and decrypting the values. Now many times we'll see such scenarios wherein there are a lot of complex functions that are responsible for encrypting the values, but we need to be very careful here. We should not go down the rabbit hole and try to understand the encryption logic. Rather we should focus on the encryption and decryption methods, which are this and looks comparatively simpler, and how we can modify the value here, right? So that should be our goal. So first, once we have identified that this is the application logic that is responsible for encrypting the values, we should try to replicate this code in any language that we are comfortable with, or we can build a Frida script to accomplish the same. For this example, I am going to use this same Java code and try to replicate it in a different environment and decrypt the values that are coming in the response. Let's copy this code and go to a browser. I'm going to type run Java online because I want to run this code in a standalone different environment. Let's navigate to tutorials point. Now if you are familiar with this kind of setup, you have to paste your code over here. You can edit, you can run and type in your values, write the code, and you will see the execution over here. So it is a very simple example of hello world code. As soon as I click on the execute button, it is going to print a hello world string, plain and simple. So that's the example. Now I am removing this code and I am providing the Java function, Java class that was responsible for our encryption logic in the DEM vulnerable application. So there are a few things that we need to rectify here before we can get the output. But first let's just click on the execute and observe the error and try to solve the errors one by one. So I'm going to click on execute. Now first is the package android.util does not exist because this is not an Android environment. This is a Java environment. So let's search base 64 in Java. This is how I typically reverse the encryption logic. So if we find some good resource which will give how to declare base 64 in Java, so we need to import Java util base 64, not Android util base 64. So let's replace this string over here and try to execute the code again. All right, so first error is gone. Now we have few more errors wherein it is unable to find the symbol in the decode and encode methods. So there are few things that we need to add it. Like if you are going to use the base 64 encode to string, you have to first call the get encoder. So whenever it is mentioned, we need to give this get encoder, and there is no need of this second parameter, so I'm going to remove that in the respective Java code. For the decoder, similarly we need to mention this get decoder. So I have mentioned the get decoder, and again I'm going to get rid of this second parameter. Now let me try to run this code again and see what happens. Alright, so most of the errors are solved. Now it is sorted, but it needs a main method, so I'm going to declare it public static void main string args. If I don't do anything, it will still run system.out.println, but I am just calling a method to print this string, and it will get rid of all the application, all the errors, but it still has some error because I forgot to mention the t. So now it is correct, print ln. Cool, so now it works. So we have no error in this code. So now this code should be able to decrypt the values that are coming from the server or being passed in the request. But as we have seen in the request, only the login method is passing the parameters, but no other request is passing any parameter, but only values are coming from the server. So now navigating back to our Burp Suite. So we saw this balance API call. So there were no requests, but there was a response, and it had this string. So I'm going to copy this, and I will try to decrypt it with our custom function. So how do we decrypt? We need to call this method. This is a decryption method, this is an encryption method. So I'm calling this a method from the same class, and I am just providing this string that I have copied from the response. Let's try to decrypt this. Now look at this JSON response closely. Alright, so it gave us the 200 HTTP message code, and it gave us the $10,000 value, that is this user's balance and this user's account number. So we are able to actually decrypt this encrypted text from the server. Now this is fine, but in order to really exploit this, there is one scenario, and there could be many more such scenarios. If we think of a test case that we want to fetch some other user's bank balance, like if the user I have logged in is user 1 and his account number is this and his balance is this. What if I want to fetch user 2's bank balance, correct? So that should be our target when we are pen testing an application. So how can we actually do that? So at a client side, there has to be some values that it is sending to server, and server recognize those values and send the corresponding response in the HTTP response. So this is user 1's value. Now how the server is actually identifying that user 1 is logged in? So if we go back to this request, in the request section there are no parameters, but there is this authorization header. Now this is a JWT header. So we are going to copy this, and we are going to head towards our browser again. I'll open jwt.io. That will give us a little description about the JWT. So it's a JSON Web Tokens, and they're open industry standard RFC 7519 method for representing the claim securely between two parties. So in our case it is a Android application and the server. Now this website allows you to decode and verify plus generate the JWT token. If you look at the warning, it says JWTs are credential. It means it should be handled carefully. These tokens can grant access to resources, so be careful when you are pasting it over here. This application, this jwt.io website, do not record tokens. All the validation and debugging is done on the client side. So this is a sample token. I'll remove this token and I'll paste the token that we have copied from the our Android app request. So if you look at here, this is the interesting part. It has username and it has this flag that says is admin false. So focusing on this one right now, so the application is sending the user one in this format. That's why the server is responding with this user's balance and other API calls like balance, inquiry, transactions, history and everything, correct? Can we modify this? Let's try. I'm going to just modify this to user2 and I'm going to copy this modified JWT. Going back to our example, let's take this request into repeater. Alright, encrypted data, everything. I'm replacing this with user2's token, clicking on the send button again. Now I've got some response, but I don't know what it is, whether I have received the user2's balance inquiry or not. I don't know right now. Let's copy this, going back to our compiler. I'm replacing this encrypted text over here. Let's execute. No, I'm getting the 403 forbidden invalid signature. It means that the server is validating the integrity of this token, the JWT token. Now it is signed with a secret key. So there is one scenario wherein if the developers have not kept a strong JWT secret, we can brute force that string. So there are multiple tools available in market to do this task, but for this example I am using the crack JWT tool. So I have that open up over here. It is built with Python. So this is the command Python, this file crackjwt.py, and this is also a file JWT where I have kept the our JWT token from the request response, and you need to give a word list. So this will brute force the different strings from our given word list. Let's try to crack this JWT. Alright, so it was able to find the secret key, and it is literally the word secret. Now copy this secret. So now we can use the secret to sign the JWT tokens. Navigating back to jwt.io. Now remember, this is a modified JWT token with user2. So if you want to sign this, you have to paste your secret here, and see this site is also saying weak secret. So yes, it is weak secret because this is a vulnerable application. Now let's copy this newly signed token and go back to our burp suite, removing the old token and replacing the new token with user2 username, repeating the request. I got some other response this time. Copying this, going back to our decryptor method. I'm removing this which had the error message, placing the new value over here. executing the code. Now if you look at here, it says data balance 10,000 and account number 222. It means the account number has changed. Now let's try to decrypt few more values. So what I'm going to do is I'm going to write the same method, or we can keep a separator over here so the values look little cleaner. And try to fetch the values from some other API. So we had this transaction API, so I am taking this into repeater. Let's see what this user got in his transactions. So system.out.println, calling the method A, which is a decryption method. All good. Executing this code. All right, so a totally new response. So this is the transaction history of user A, user 1, from account 111 to 222, from account 222 to 111, 111 to some 333 account. This is the amount. So if you see in each of this data set, the user 111 is involved because this is the history of the user 1. Now with same technique, let's try to print the user 2's data, because now we have a secret, so we can modify the JWT. So right now I'm removing these values. So over here we have the token of user 2 and it is signed, so the application, the backend, is going to accept it. So I'm copying this again, going to a burp suite, removing the old JWT token of user 1 and replacing it with the JWT token of user 2. Sending the request, got a response. Let's try to decrypt this in the over here. All right, if you compare these two values, so this is a account or transaction history of the user 2. So imagine this in any of the banking application. If you are able to fetch some other users critical information like PII or banking related information, transaction, balance, anything, so this could result into a critical vulnerability. So that is a high level example of how you should approach this, the dynamic checks, and how you play with APIs when you are testing the Android application. So in your journey to Android testing, you are going to come across such scenarios very often. Now you may drop your questions. I hope you learned something new in this video. See you in the next one. Thank you.